Hello everyone, this is a video for Math 180 and this is to support the material in section 14.1. So basically the idea of tessellations using half turns and the connection to translations. Okay, so the thing I want to demonstrate is that any quadrilateral will tessellate the plane if you do it this particular way. So here's an example. Here's a quadrilateral, right? It's, 1, 2, 3, 4 vertices. And I've labeled the angles, angle 1, 2, 3, and 4. And kind of the important thing to keep in mind is we know from our geometry section, if you remember, that the 4 angles of any quadrilateral have to add up to 360. So these 4 angles, I don't know what they are, but I know that if you add all 4 of them up, you'll get 360. And 360 is a full circle. Okay. And now if I want to think about how to tessellate it, the idea is I'm taking a bunch of copies of this and rearranging them, putting them together so that there's no gaps, there's no overlaps. And so here's how I'm gonna do it. So I just made a copy of this guy. And the fun thing about this is it works with any quadrilateral. So if you're working with kids, they could do this themselves. Now the underlying grid, you actually don't need it, but I like it as an added structure. It helps you with the precision, right? And notice I've made it, this particular one, just to help me, I've made it so that it's easy to see the midpoint of each side. So like right here, right here, right here, right here. Those aren't vertices, those are just the midpoint of each of the sides. Okay, so start with this, and when I say by doing half turns, the idea is you pick any of your sides. So let's pick this side here, find the midpoint, and you do a half turn around that midpoint. So basically I take my thing here and I do a half turn, 180-degree rotation around that point. And you can see here where this is why I like having the dots, because it helps me be precise. I know where those go. So once I do that half turn, it would look like this. Now notice, because I went around the midpoint, the 2 vertices basically traded places. So the side lines up with itself perfectly. And notice now I have right next to angle 3, I've got angle 2, and here right next to angle 2, I've got angle 1. So now I'm going to go in and draw that guy in. Okay, and this is now angle 2, this is angle 1, this is angle 4, and this is angle 3, okay? So now I've got 2 of them. And the cool thing we showed in class is if you do a half turn and then another half turn, it's the same as a single slide. So let's demonstrate that. Now I pick another side. I don't pick the same side here because this would just rotate it back on that. Pick a different side now and do a half turn around that. And again, this side lines up with itself. I have to that's why again I like the dots. It helps me be precise. That vertex would be there and this vertex would be here. Okay. So it would look like that. Let's draw it in. It's like this, right? Yeah. Okay. So let me put this this back on so that we can see for sure. Wow, I have this, okay, that was like that, right? So that means this was angle 4, this is angle 1, this is angle 2, and this is angle 3. And here's kind of the cool thing again we showed, is that to go from here to here, how did I do it? I did it by 2 half turns, right? I did half turn around here and then change the center and do a half turn around there. So I got from there to there doing 2 half turns. However, I could have done the same thing by a single slide. So that's kind of this cool thing on transformations, that half turns and translations are sort of related to each other. Any translation is equivalent to a combination of 2 half turns. Okay, so now I'm going to do it one more time, but I'm going to be systematic. I'm going to choose this midpoint here. Okay, so if I choose that midpoint and spin it around, sorry, I didn't do it well, but it would line up like this. So notice, that's perfect, that's perfect, that's perfect. The only new one I need is this. And take a look here now. This is angle 4. This is angle 3. This is angle 2. And this guy here is angle 1. Okay. And now kind of notice that this guy is the same as that guy by translation. Which the reason, because it's, again, it's a double half turn, right? I take it half turn and then do another half turn. So that's kind of cool. But here's the important thing to know, that it's a tessellation. Look at this vertex here. It's surrounded by 4 angles, angle 1, angle 2, angle 3, and angle 4. And why do I know that that matches up perfectly? Why do I know there's no gap and there's no overlap? Well, remember, in the quadrilateral, I knew those 4 angles add up to 360. Therefore, by logic, this adds up to exactly 360 and everything fits together perfectly. So that's kind of the proof. All the sides line up with themselves, and around every vertex, you're going to wind up with each angle of your quadrilateral exactly once. Let's do it at another spot so that you see. So here at this, here I already have angles 3 and 2, right? So if I do it this way, oh, sorry, here it is. If I spin it around this one, whoa, that's not a very good spin, but you can kind of see, now I know this guy goes here and this vertex goes here. So draw it in. Okay, and so now this is angle 4, this is angle 2, this is angle 3, and this guy here is angle 1. And now lastly, spin it around this one. So take it, do a half turn around the midpoint of this side, and it lines up like that. And so I need that point. And hopefully now it's becoming clear that this is going to work. Basically, this is angle 4, this is angle 2, this is angle 3, and this is angle 1. And notice, just like I said, around this point here, I've got angle 1, angle 2, angle 3, angle 4. So those 4 angles add up to 360. So I know it's going to match perfectly. So you could continue doing this, and then, you know, like this would be one of them. And I could fill up the whole plane, go in whole directions. In fact, you can kind of think about it. If you keep doing it sort of this way, spin it, spin it, spin it. That kind of makes like a strip. And then when you spin it by one of the other ones, you got it here, and now I could start spinning this guy and make it a second strip. So you can systematically talk about how you know it's gonna turn out. And you can also kind of think about it in terms of coloring, because this will wind up allowing for, trying to find the right marker, sorry, a checkerboard pattern. So in other words, I can color it in a way that I get a checkerboard. Now notice, in fact, the ones I'm going to color in are every other one. So the ones I color in are sort of translations of each other's. Right, so notice this, from this one to that one, that would be a translation. For this one to that one would be a translation. And the ones I haven't colored in, same thing. So that's pretty cool. Let me draw in a couple more. Now that you know the sort of pattern, you can be careful, but you can get the general look. This one would look like this. And now you start to see the strips, right? I should not do it freehand. Sorry. Okay, so and then this one would be colored in. So I could fill up the whole plane with these quadrilaterals. So this will work for any quadrilateral. So you can take any quadrilateral and do this method. So you're generating the pattern by using half turns. And the half turns are around the midpoint of the sides. Okay.